YouTube channel. My name is Mafe Iyinoluwa. Today I'm going to be talking about studying chemistry 101 for beginners. For my last video, which I asked that how to know if a person has HIV or not, well, the answer is no. You can never know because the person's body is covered with clothes, with socks, hats, glasses, masks. You can never know if the person has HIV or not. So today is studying chemistry 101 for beginners. The topics I have here with me are introduction to chemistry, matter, everything about matter, nature of matter and separation techniques, elements, compound, mixture, atoms, molecule, and ion. And so let's get started. Introduction to chemistry. I have meaning of chemistry. Chemistry deals with the composition, uses, and properties of matter. It deals with how matter goes, the properties of matter, the uses of matter, the composition of matter, everything about matter. That is what chemistry deals with. And it also deals with a lot of experiments, scientific methods, and laws and formulas and all of that. So now we are going to scientific method. This is how scientists do figure out their experiments and how they figure out a law, a theory, or medicine, or everything they want to figure out. It can be given in a table, and it is said, according to scientific method, it goes from the observation to the pattern. This is an example of the diagram. I hope you can see this. From a given set of observation, it leads to a pattern, then a problem, then the experiments, and if it gives a negative result, it goes another way. So I hope you've all seen it very clearly now. So let me now explain everything about that table. From a given set of observation, it leads to a certain pattern. They see a certain pattern. This often leads to a problem which they try to solve. Then they put forward a reasonable explanation or hypothesis and put forward an experiment to test it. Then they carefully record their observation and the result of their experiment. If the experiment supports their hypothesis, then they carry out further investigations and discuss with these other scientists in the field so that it can be further tested. And if this experiment has been further tested and proven to be true within the limits of available evidence, then it becomes a theory or a law. But if the experiment doesn't support the hypothesis, then the scientist goes back to his hypothesis and either modifies it or puts forward a new hypothesis. So now we are going to the uses of chemistry. Chemistry is used for a lot of things. We use chemistry for food, for clothing, for military and space science, housing, medicine, transportation, etc. So now we are going to careers in chemistry. There are a lot of careers in chemistry. For example, for health service, food processing, petroleum and petrochemical industries, manufacturing industries, extractive industries, a lot of things, a lot of careers are there in chemistry. So now we are going to matter. Matter can be defined as anything that has mass and occupies space. What is this trying to say? It's trying to say that matter is anything that has mass, and mass can be defined as the mass of an object. The mass of an object is the quantity of matter that object contains, and it is the same everywhere. So as we all know the meaning of matter like that, now let us break it down. We know the meaning of matter. Now for occupying space. Our world is made up of matter because our world occupies space. We have different countries in this earth. We ourselves, the food we eat, the water we drink, even the air we breathe. If I can say we ourselves are matter because we are anything that occupies we are everything of mass and occupy space. We have mass and we occupy space. So properties of matter. There are two properties of matter. We have the physical properties and the chemical properties. The physical properties are those properties that are associated with physical changes. Common physical properties include the boiling point, the melting point, the density, the hardness, and as so much like that. Even color, odor, and taste are examples of physical properties. What this is trying to say is that it is associated with physical changes. An example of physical properties are the melting point, the point that it goes through to form a new substance, to form things. The boiling point, the melting point, and all sort of that. So now chemical change, chemical properties. Chemical properties involve when matter undergoes a change to form new substances. An example of this is when you rust iron. When you rust iron, it gives iron rust. It forms a new substance which gives iron rust. So now we are going to physical change and chemical change. Physical change is one which is easily reversible and one in which no new substances are formed. This is a very simple thing to assimilate. What this is saying is that physical change deals with it is easily reversible. You can reverse it. Once you've changed it, you can reverse it back, and there's no new substances are formed. It is the same substances you put forward. That's what it will give you when it is put backward. An example of this is when salt and water goes through a mixing point, it gives you salt solution. But the backward reaction is when the salt solution is in evaporated, it gives you salt and water. So you can see that there's no new substances formed. There's no new substances formed, and there's nothing new except from the forward reaction and the backward reaction. How to make sure you get the same thing? That is what physical change is all about. And chemical change is one that is not easily reversible and one in which no new substances are formed. Since physical change is one that is easily reversible and no new substances are formed, chemical it is not easily reversible and new substances are formed. An example of this is when you burn wood. When wood goes through a burning point, it gives you ash plus gas. It gives you ashes and gases. But it can't be reversed. Okay, how will you change How will you change ash and gases together to give you wood back? That is what we call a physical change. It is not easily reversible. You can't easily reverse it back. So now we are going to element, compound, and mixture. Elements is a substance that cannot be split into smaller units by ordinary chemical process. We all know chemical process goes back and forth. It doesn't go back and forth. So we have classification, and we all know that there are 109 known elements. 90 of them, this is a fact, 90 of them occurs naturally and 19 of them are artificially made in the laboratory. So now we are going to classification of elements. Elements are classified into two. We have the metal and non-metal. Metal are those substances, elements which ionize by electron loss, which ionize by electron loss. An example of this is magnesium, calcium, iron, etc. And non-metal are those elements which ionize by electron gain. An example of this is chlorine, oxygen, nitrogen, iodine, etc. So now we are going to compound. Compound can be defined as a substance that contains two or more elements chemically combined together. What this is trying to say is you can combine elements together to make a substance. For example, water. The component elements for water is hydrogen and oxygen. It gives water. They chemically combine together to give you water. And the formula is, we all know the formula for water, H2O. It is a common thing. Sodium. Salt. The component of salt is sodium chloride. And we all know the formula, NaCl. It gives salt. And there are a lot of that. We have limestone, which is calcium, carbon, and oxygen, which is Ca, calcium carbonate 3. Calcium, carbon, oxygen. So we are going to mixture. Mixture contains two or more constituents that can be easily separated by physical method. Example of mixture is air. You all know the common constituents in air are oxygen, carbon dioxide, nitrogen, etc. The one for milk, we have water, sugar, fats, proteins, mineral salts, and vitamins, etc. So now we are going to separation techniques. This separation techniques deals with how things are separated. Since a mixture contains two or more different substances. Yep. So how things get separated. So now separation techniques, it is the making use of physical properties. It is used for separating some physical properties. And types of separation techniques are sieving. We use sieve to separate solid particles of different size. For example, a typical example of sieving is when you want to sieve rice on fire. You all know that the solid particles, which is the rice, stays in the sieve, while the liquid particles are separated from the solid particles. So the liquid particles are drained away, while the solid particles still remain in the sieve. So what we are trying to say that this is separated from solid particles and non-solid particles. So we have magnetic separation. A magnetic separation is used to separate magnets from non-magnetic substances or particles. Sublimation. This is when some particles are heated, they sublime. For example, they change directly to gaseous parts without even passing to the liquid part. Example of such solids are iodine and ammonium chloride. So now we are going to filtration. A porous material like filter paper can be used to separate insoluble particles from liquids. What this is trying to say is that filtration is just like sieving, but it's kind of tiny filter paper that is used to separate particles from insoluble particles. It is used to separate insoluble particles from liquids. So now we are going to atoms, molecules, and ions. Atoms, according to some chemistry students, you all know atoms can be defined as the smallest particle of an element which take part in a chemical reaction. And molecules are the smallest particle of a substance that can normally exist alone and still retain the chemical properties of the substance. So ions can be defined as any atom or group of atoms that possesses an electric charge. An example of this is positively electric charged ions are called cations, which gives a positive VE, and negatively charged ions called anions gives a negative VE. So now, in the beginning of the video, I said chemistry deals with formulas and all sorts of that. So atoms are, some scientists brought some of their ideas and some laws about atoms when experimented, when their results gives a law. So in 1808, John Dalton proposed the atomic theory, which include all atoms are made up of small indivisible particles called atoms. All elements are made up of small indivisible particles called atoms. And this is we know in the definition of atoms itself, atoms can be defined as the smallest particle of an element which can take part in a chemical reaction. So the second law of Dalton's atomic theory is atoms can neither be created or destroyed. What this is trying to say is that you cannot create atom and you cannot destroy it. The third one is atoms of the same kind of element are alike in every aspect but differ from atoms of other elements. What this is trying to say is that atoms of the same element, like atoms in an element, are alike and are alike in every aspect, in every kind, in every characteristics. They are alike, but they are different from atoms of other elements. That's what that one is trying to say. And the fourth one is when atoms combine with other atoms, they do so in simple ratio. An example is this is H2O. Because hydrogen is an atom, but when it combines with other atoms, they do so in simple ratio. So the fifth one is all chemical change results from the combination or separation of atoms. What this is trying to say is that every chemical change is either from the combination of atoms or the separation of atoms. So, scientists, when they bring up a law, some people do go against it and prove it wrong. Well, Dalton's atomic theory was proven wrong by Rutherford's discovery, which associated that the first one, which was all elements are made up of small indivisible particles called atoms. All elements are made up of small indivisible particles called atoms, has been proven wrong by Rutherford's discovery, which expatiates on atoms are made up of three subparticles, which are called the proton, electron, and neutron. The second one, which says atoms can neither be created or destroyed, this statement still holds good for an ordinary chemical reaction. For example, during the nuclear reaction of fission of uranium-235, the nucleus is broken into smaller units which form simpler atoms. So atoms are created in that aspect. And while tremendous amount of heat energy is released. So these changes that occur during nuclear fission destroys the atoms of the elements involved. So this is trying to say that atoms are destroyed. So it has been proven wrong that atoms can be created and can be destroyed. So the one of atoms of the same element are said to be alike is not true in every aspect. It's not true because chloride, for example, chloride has two different atoms or isotopes which differ in their neutron content. So that law is not true because chloride has two different atoms and their neutron content are different. So the fourth one, which says that when atoms combine with other atoms, they do so in simple ratio, is still generally true for inorganic compounds, which contains few atoms per molecule. For example, carbon. Carbon forms very large organic molecule, such as protein, fat, and starch, which contains thousands of atoms. So now we have everybody all knows the 20 periodic table, and if you don't know, they are hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, and potassium with calcium, and they all have symbols and atomic numbers. So that's all for today, guys, and that is everything about Chemistry 101. We meet next time in Study Chemistry 102 for beginners. And if you don't understand anything or any topic here, you can as well comment below and say your thing and ask some questions, and in Chemistry 102 I'll answer all questions. And summary of everything, we all know chemistry deals with the composition, properties of uses of matter. We all know the uses of matter, the careers in chemistry, uses of chemistry, the scientific method. We all know matter. Matter can be defined as anything that has mass and occupies space. The mass of an object is the quantity of matter that object contains, and it is the same everywhere. And we all know the properties of matter, the differences, the chemical change and physical change, the physical properties and chemical properties. And lest I forgot, since I've given the definition of physical properties and chemical properties, you can differentiate between them. Is that right? We all know chemical changes is easily reversible, and chemical change is not easily reversible, while physical change is easily reversible. And no new substances are formed in physical change, while new substances are formed in chemical change. And we all know the classification of elements, the metals and non-metals, the compounds, the examples of compound, common salt, limestone, sand, water, mixtures. Meaning of mixture, an example of mixture, I've given an example: air, which contains oxygen, carbon dioxide, and nitrogen. Separation techniques, different way through which things can be separated: the sieving method, the magnetic separation, the sublimation, the filtration. There are also different types. We have decantation, we have crystallization, we have evaporation. We all know evaporation. Evaporation goes through boiling points. And we all know matter exists in the various forms. We have matter exists in solid, liquid, and gaseous. And modifications of Dalton's atomic theory. We all know that Rutherford's discovery has put most of Dalton's atomic theory has been proven wrong by modifications of Dalton's atomic theory. And we all know the elements and symbol. Lest I forgot, the symbol of hydrogen stands for H. The symbol of this is an example of the 20 periodic table, their symbol and their atomic number. As you can see, it's listed 20 there. The atomic number simply means the number they stands for. Since hydrogen is the first element, since the atomic number will be 1 and the symbol will be H. Since helium is the second element, the atomic number will be 2 and it stands for He, and so on like that. So that's everything about everything I've said, and that's all. Don't forget to like, comment, share, and subscribe on this video. Thank you. Bye. See you next time in my Studying Chemistry 102.